Let's take a look at this one. This is number 1 in our group. They're asking us to solve 3 5/9 divided by 2 2/3. 3 5/9, and that's divided by 2 2/3. Well, as mixed numbers, it's going to be hard to divide, so what we'll do is we'll make them improper fractions. We'll multiply 9 times 3 is 27 plus 5 is 32, for the denominator of 9. And we'll divide this by 3 times 2 is 6, plus 2 is 8. We'll divide this by 8/3. But really, when you divide, what you end up doing is you end up just taking the inverse of your divisor, which is, in this case, just flipped on top 3/8, and then we're going to multiply. So we have 32 divided by 9 times 3/8. This reduces to 3, and this will reduce to 4. This is equal to 4/3. And 4/3 is an improper fraction. We have to make this improper fraction into a mixed number, and that would be 1 1/3. Because 3 times 1 is 3 plus 1 is 4. And that's our answer. The next one we have here is solve 56 minus a minus 42. 56 minus a minus 42. This is just 56 minus a minus is plus 42. And 56 plus 42 is 98. Now you might see quite a few of these minuses. Then you have a number. Pick a number to say 8. This would be minus, plus, minus, plus, minus 8. So that number would be negative 8. You might have it like this too. Minus, 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 minus 8. So this is minus, plus, minus, plus, minus, plus. So this number would be plus 8. And as you get on and as you move on more in your discovery and application of arithmetic, you'll see that you actually use things like this. Maybe not this much with 5 or 6, but you certainly will. You certainly can run into problems that have 4 negative symbols in a row. It happens quite frequently, and you'll see that as you move up in grade. We're going to be looking at this one, which point in the number line below is closest to negative 1 2/3. So we have this number line at 0. We go to this way, we're going negative. So we go negative 1 2/3. Because if you take any of these, you can always take one of these and make it into thirds. 1, 2, 1, 2, 3. Like here. 1, 2, 3. So we're at the 2/3 mark here. So this would be where the point is at negative 1 2/3. Brings up the next. They want us to simplify this, and there's a rule that You might be familiar with this. Please excuse my dear Aunt Sally. And what it says is do what's in parentheses first. Do that. And then you do your exponents. And then you do your multiplication or division left to right. So we have a division here. And we have a division here. 8 divided into 32 is 4. So we have 7 plus 4, that equals 11. It's very important that you follow the procedure PEMDAS, realizing that these have equal precedence. No, one is not stronger than the other. They just, when you hit multiplication and division in the same line, you just work from left to right. So we had division in this case, a division here, and a division here. Carlos bought 3 gallons of ice cream for $9.50. Which proportion can be used to find the cost of 7 gallons of ice cream? So we're talking proportion. It's important that you keep it straight, but we can talk about gallons, and we can talk about price. That's one possibility. And then we could have we'd have 3 gallons is to $9.50 as 7 gallons of ice cream is to an amount that we don't know, the amount of money. You could do the problem like this. This is using the gallons on top and the money on the bottom. But you could also set it up the opposite way, with money on top and gallons on the bottom, and it will work out the same way. That would be $9.50 is to 3 as the money, as our money, which we don't know, is to 7. So we have our gallons on the bottom here, and we have gallons. These are gallons on the top here, and these are gallons on the bottom here. Now, why doesn't it make any difference whether you have them on top or bottom? As long as you have it set up exactly the same way. Money on the top, gallons on the bottom, or gallons on top with money on the, or gallons on top with money on the bottom, you get the same result. And the reason is, if you cross multiply here, you're going to get 3x, 3 times x equals some money. And if you multiply here, you notice that you still end up with 3 times some quantity equals some money. As long as you're consistent going across, dollars on top, gallons on the bottom, the problem will work out for you.